Now we will discuss in detail conjugate of a complex number. Here we will discuss some properties of conjugate of complex number. As we earlier defined, conjugate of a complex number is obtained by changing eta to minus eta. So, if we have a complex number z is equal to a plus eta b, then conjugate of z, that is z bar, is equal to a minus eta b, changing eta to minus eta. So after changing eta to minus eta, we will get a new complex number that is called conjugate of complex number. Now we will discuss some properties of conjugate of complex number. So there are some properties. Conjugate of complex number. So turn by turn we will discuss the properties of conjugate of complex number and we will prove these properties. So the first property is, that is conjugate of complex number, then again taking the conjugate of that conjugate, this will give again the original complex number, not real, it is the original complex number. So let z is equal to a plus eta b. So according to left hand side, if we see, we have to find double conjugate. So conjugate of this is, by changing eta to minus eta, it becomes a minus eta b. Now this is our complex number. Now we have to take the conjugate of this complex number. So what will happen? That is going to happen by taking the conjugate of this conjugate complex number. We have to again change eta to minus eta. So changing eta to minus eta, what is going to happen? Let's see. So we get a minus of minus is plus eta b. If we see that, we get again our original complex number, that is z. So the first property is true. So double z bar, that is double conjugate of a complex number, it gives again back to our original complex number. So the next one is, now the second property is, that is z plus z bar, that is conjugate, divided by 2 is equal to real part of z, and z minus z bar over 2 eta is equal to imaginary part of z. So what are the real and imaginary part of a complex number? We are already familiar with that. So we are going to prove this result. Let z is equal to a plus eta b, where a is the real part of z and b is the imaginary part of z. So we have to prove z plus z bar is z plus z bar over 2 is equal to a, and z minus z bar over 2 eta is equal to b. So let's start. We have to find z bar, that is a minus eta b, by changing eta to minus eta. Now this is number 1, this is number 2. So we have to find addition and subtraction of these two equations. So adding 1 and 2 and subtracting 1 and 2, that implies, and that again implies, that implies z plus z bar is equal to 2a, and here z minus z bar is equal to 2 iota b. So from this, if we see that z plus z bar over 2 is equal to a, that is real part of z, and z minus z bar over 2 iota is equal to b. So here if we see that we get z plus z bar over 2 is equal to real part of z and z minus z bar over 2 iota is equal to imaginary part of z. So the result is proved. The next property is that is going to define z is equal to z bar if and only if z is real. That is, proof is here. Let z is equal to a plus iota b and z bar is equal to a minus iota b. So z is equal to z bar if and only if, that implies a plus iota b is equal to a minus iota b. So that gives 2 iota b is equal to 0. As 2 is not equal to 0, iota is not equal to 0, that implies b is equal to 0. That means z is equal to a plus iota b becomes a plus iota 0. That is equal to a. That is the real number a. Therefore, we can say that, and we have proved that z is equal to z bar implies z is real. Sorry, it is only if and only if z is real. So if z is real, that means z is equal to z bar. You can see that if z is real, that is a converse part. That is imaginary part is 0, z is a plus iota 0. So what about its conjugate? Conjugate is z bar, that is a minus iota 0. So we can say that z is equal to z bar. Therefore, if z is real, implies z is equal to z bar. Therefore, combining above two results, z is equal to z bar if and only if z is real. Now the next property is, that is number 4, z bar is equal to minus z if and only if z is purely imaginary. As we done earlier, z is equal to z bar if it is purely real. Now it is purely imaginary. So let z is equal to a plus iota b and z is purely imaginary. That means a is equal to 0. Therefore, z is equal to iota b. So now we are taking the z bar. Z bar is changing iota to minus iota. So if we see that, it becomes minus of iota b, that is minus z. So if z is purely imaginary, then z bar is equal to minus z, and now taking the converse, let z bar is equal to minus z. As z is equal to, in general, a plus iota b, so conjugate of z is a minus iota b is equal to minus a plus iota b. That gives a minus iota b is equal to minus a minus iota b. That gives 2a is equal to 0. That implies a is equal to 0. That is, z becomes 0 plus iota b. That is iota b. That is purely imaginary number. Therefore, if z bar is equal to minus z, if and only if z is purely imaginary. So, combining these two results, we get z bar is equal to minus z if and only if z is purely imaginary. The next property is, that is fifth one, that states that z1 plus minus z2 whole bar is equal to z1 bar plus minus z2 bar. That means if we say z1 plus z2 whole bar, then it is equal to z1 bar plus z2 bar. Also, if we have z1 minus z2 whole bar, which is equal to z1 bar minus z2 bar. So the proof is, first we assume let z1 is equal to a plus iota b and z2 is equal to c plus iota d are two different complex numbers. Now we have to take the product and difference of these complex numbers. Now z1 plus z2, that is a plus iota b plus c plus iota d. So that gives a plus c plus iota b plus d, and z1 minus z2, that gives a plus iota b minus c minus iota d. It becomes a minus c plus iota b minus d. Now we have to prove this sum whole bar. Now taking left hand side, we get z1 plus z2 whole bar. That becomes a plus c, changing iota to minus iota, b plus d. It becomes a plus c minus iota b minus iota d. That gives a minus iota b plus c minus iota d. So if we see that this is the conjugate of z1, so it is z1 bar, and this is the conjugate of z2, so that is z2 bar. So this relation under addition is proved. Now taking the minus sign, Z1 minus Z2 whole bar, that is A minus C. Now changing iota to minus iota, it is B minus D. It gives A minus C minus iota B plus iota D. So it gives A minus iota B, and next minus C plus iota D, that is minus is common in the bracket C minus iota D. If we see that A minus iota B is Z1 bar and C minus iota D is Z2 bar, that is Z1 minus Z2 bar is equal to Z1 bar minus Z2 bar. Therefore, by combining left hand side, we get Z1 plus Z2 whole bar under plus minus sign, Z1 bar plus minus Z2 bar. This result is due for addition and subtraction sign. So the next property is that is number 6 property, that says that product of two complex numbers, now taking the conjugate of that, is equal to Z1 bar into Z2 bar. So product of conjugate of product of two complex number is equal to product of conjugate of two complex number. So we are going to solve in the same manner. That is very simple. Let Z1 is equal to A plus iota B and Z2 is equal to C plus iota D. Then Z1 bar is equal to A minus iota B and Z2 bar is equal to C minus iota D. Now we are going to take left hand side. So first of all we will find the product of Z1 Z2. So now Z1 into Z2, that is A plus iota B into C plus iota D. That gives A into C, that is AC, A into iota D, that is iota AD, iota B into C, that is iota BC, iota into iota is iota square into BD. As iota square is minus 1, so it becomes AC minus BD in the one bracket plus iota, taking common from these two terms, and in the bracket we are with AD plus BC. Now we have to take the conjugate of these two terms, that is AC minus BD minus iota AD plus BC. Now taking right hand side, this gives names as number 1. Now taking right hand side, that is Z1 bar into Z2 bar, that is A minus iota B into C minus iota D, that is AC minus iota AD minus iota BC plus iota square BD. So it gives AC minus BD again by taking iota square is equal to minus 1 here, and now taking the minus iota common, we get AD plus BC. This is number 2. So from 1 and 2 we can judge the result. So from 1 and 2 we get Z1 into Z2 bar is equal to Z1 bar into Z2 bar, that is 2. So next property is, that is quotient of two complex number is equal to is the individual quotient of conjugate of two complex number. So Z1 Z2 quotient whole conjugate is equal to Z1 conjugate over Z2 conjugate. That is same as in the case we have done in subtraction, addition and multiplication. Now it is the turn in quotient form. So in the quotient form we have, and this is the last property of our conjugate of complex number. So in this property, first of all again, we will take let Z1 is equal to A plus iota B and Z2 is equal to C plus iota D. So again in this we have to find quotient of this. So now Z1 over Z2, that is A plus iota B over C plus iota D. To convert denominator in a number, that is converting it into a simple form, we will take the conjugate of denominator and multiply and divide by the whole term. It gives AC minus iota AD plus iota BC minus iota square BD over A square minus B square. So it gives AC plus BD by putting the value of iota square is equal to minus 1 and taking plus iota BC minus AD over C square minus iota square D square. So here we get AC plus BD plus iota BC minus AD over C square plus D square. Now taking left hand side, that is Z1 over Z2 whole part, that is AC plus BD minus iota BC minus AD over C square plus D square. Now taking right hand side, that is Z1 bar over Z2 bar, that is A minus iota B over C minus iota D. That gives A minus iota B over C minus iota D into C plus iota D, again taking the conjugate of denominator and multiply and divide by the whole fraction. That is AC plus A iota D minus iota BC minus iota square BD over C square plus C iota D, here we can apply A square minus b square. I forget here, that is a minus iota b, and c plus iota d, that is a minus b, and a minus b and a plus b, that gives a square minus b square, c square minus iota d whole square, that is ac plus bd plus iota, that is ad minus bc over c square minus iota square d square, that is ac plus bd plus iota ad minus bc over c square plus d square, that is ac plus bd minus iota bc minus ad over c square plus d square, that is number 2. So, from 1 and 2, we get z1 over z2 whole bar is equal to z1 bar over z2 bar. That was the last property of conjugate of complex number.